Okay, here we go. Today, hopefully you're having a great day. I didn't mean to do that, so I had to undo. I wanted to do it full screen. Okay, here we go. So back to here, struggling here. So here we go. So today we're on section 3.6. The first day of it, we'll spend 2 days on it. We're talking about compound inequalities today, and specifically the ones that have an and in them. So by the end of the video, I hope you can say I can solve compound inequalities containing the word and. So, difference in parents. So here's a story for you to relate to and or statements. So the question is, what kind of parents do you have? Do you have the and parents or do you have the or parents? An and parent would say this, before you go out tonight, you have to clean your room and do the dishes, where an or parent would say, before you go out tonight, you need to do the dishes or clean your room. So there is a choice with the first one. Second one, there is not. So when we're dealing with inequalities, it'd be something like this. X is greater than 2 and x is less than 6 would be one option. Okay, the other type of inequality would be x is less than 2 or x is greater than 6. So when we're dealing with inequalities, compound inequalities containing the word and is the overlap of the two graphs. So if I have the first inequality of x is greater than or equal to a -3, we know we'd have a closed circle at the 3 and arrow to the right. Okay, if we have the inequality x is less than or equal to 7, we know we'd have a closed circle at the 7 and an arrow to the left. Now, for the inequality, compound inequality, x is greater than or equal to 3 and x is less than or equal to 7, we would have two solid dots at the 3 and at the 7, and the solution for that would be the overlap of the first two, so between 3 and 7. So, since some of you have said that you are not listening to me, I hope I posted some things that you might take some time to read. So, you can write a compound inequality involving and as a single inequality. So if we take a look here, these two inequalities, x is greater than or equal to 3 and x is less than or equal to 7, can also be written as 3 is less than or equal to x is less than or equal to 7. So how does that work? Let's take a quick glance at it. X is greater than or equal to 3 and x is less than or equal to 7. So I call them the sandwich technique. We put the x in the middle. This side of the inequality stays the same. So less than or equal to 7. This side we simply flip so that the x is behind. So I'd have 3 less than or equal to x. So we end up with very similar inequalities that mean the exact same thing. So when I continue on here, so if I were to look at these, what compound inequality represents the phrase all real numbers that are greater than a -2 and less than 6? So we're going to start out with the first method where we have an and in between them. So I would have x is greater than a -2. The and this part right here says x is less than a 6. So there would be the compound inequality written with an and. If I wanted to write it as one sandwiched inequality, I would put my smallest number first, my largest number in the end. My x is going to be in the middle. So how do I write it? I just flip this one around. So it would be a -2 is less than x, and the second one just stays the same. So that would be your two options for writing that. For the next one, if we're looking for solutions, which means we need to solve this inequality, I'll show you a couple ways. So first of all, we were just going to look at the first part of it. Forget about the less than -1. So if I just looked at this inequality that's written on the left-hand side, we could see that I'm just going to have to add a 4 to both sides here to solve this. And I'd have a 1 is less than or equal to an m. Okay, now if I looked at this side over here and thought to ourselves how we're going to solve that, well, once again, we would just be adding a 4. So I would then have x is, or m is less than a 3. So the entire compound inequality solution would be 1 is less than or equal to m is less than 3. Or it could be written or read as m is greater than or equal to 1 and m is less than 3. Okay, so if we were to go to solve these two, we'll use that same idea of worrying about one side first. So if I cover up that, I know that I would go about and I would subtract the 2 from both sides. And I would get a negative 6 is greater than a y. If I cover up the other side, I know that I would subtract the 2 from both sides again, and I would get greater than a negative 12. So the big moral of the story is you just have to do it to all 3 sides when we're solving it. Okay, so this next one, if I take a look at this side first, I could see that I would times by a 4 on both sides. And I have 12 is greater than now an 11 plus a k. Next thing I would do, I would subtract the 11 off both sides. And I'd end up with a 1 is greater than a k. If I now switch and I cover up this side, we can see that once again I would be multiplying by a 4. And I would have a greater than or equal to now a negative 12. And then at this next step, next step, I could see that once again I would minus an 11. So I could subtract an 11 from both sides again. And now I'd have greater than or equal to a negative 23. Okay, now if we go back and graph these, which I did not do, if I go back and graph them, now all I'm going to do is require that you put 2 numbers on there. The smaller number always goes on the left, the larger number on the right. And then we just graph them the same way that we have been. So we've got a open circle at both a negative 6 and at a negative 12. And since this says that y is greater than a negative 12, I know I'm going this way. Y is less than a negative 6. So we're talking about the part of the graph that is in between those 2 numbers. Okay, same idea over here with this one. If I were to put these 2 numbers on the number line, a negative 23 and a 1, I know that I'm going to have a closed circle at the negative 23 since there's an equal to with it. I know I'm going to have an open circle at a 1. The solution is just connecting the 2. Okay, so let's flip and let's take a look at the next thing. Next thing, we're going to talk about interval notation. So interval notation is just another way to write inequalities. So the things you need to know. Parentheses are going to be used with the less than or the greater than symbol. We are going to use brackets when we have a less than or equal to or a greater than symbol. And the other thing that we're going to use that we haven't talked about is the infinity signs. So the first one is positive infinity, which means it's going on forever in the positive direction. The other one is a negative infinity, which means it's going to go on forever in the negative direction. So if I were going to try and write this inequality, x is greater than a or equal to a 2, we can see what the graph would look like in the center here. And then on the right-hand side, I know that since I have a closed circle at a a positive 2, or since I have the equal to over here, I know that I'm going to use a bracket. So I've got a bracket, the 2, which means on the left-hand side I've got 2, and it's going to go on forever to infinity in the positive direction. The reason I use a parenthesis with the infinity is because you will never actually get to infinity. It's just an idea. You never get there. Okay. If we look at the second one, x is less than a 2. So now we're coming from a negative infinity on the left-hand side, and we're going to a positive 2. And again, it's not equal to 2, so we're just going to use parentheses for both of those. If we looked at the inequality, 1 is less than x is less than or equal to a 5. Now I'm going to have an open circle at the 1, going to a closed circle at the 5, which tells me in interval notation I'm going to uh, have a parenthesis at a 1, and then I'm going to have a bracket after the 5. Okay, so and we can see that for an OR statement, you could also write a interval notation that would be written as this. Now let's you just take a look at that. Hopefully that makes sense to you. Okay, last thing, I wanted to graph this interval notation, parenthesis negative 2 comma 7 with a bracket, and then how we write it as an inequality. Let's take a look at those two things. So first of all, on a graph, I've got a negative 2, I got a positive 7. Since it's a parenthesis, I know it's going to be an open circle, that's 2. Since it's a bracket, it's 7, I know it's going to be a closed circle. So it'd simply be that. And then if I wanted to write in inequality, that went along with that. The sandwich technique works really well. I've got my smaller number over here on my left, larger number here over my right. I put an X in the middle. I know since it's an open circle, it's just going to be a less than symbol. Since it's a closed circle, it's going to be a less than or equal to symbol. So that's how you would do that one. Second one, what is the graph of x is greater than 7? So here I've got a 6, 7, and 8. I know I'm going to have an open circle since there's no equal to with it, and the arrow would be going to the right. If I think about an interval notation, that would now look like a parenthesis at the 7. And where is it going to? It's going to positive infinity. So I'm going to use positive infinity and close with a parenthesis. Okay, hopefully that stuff makes sense to you, and that is a wrap.